Problem, there's a box being pulled by an 85 Newton force, and we got to figure out what the acceleration of this box is. We know the coefficient of friction between the block and the ground is 0.3. We know the mass is 15 kilograms. All the forces acting on this object are drawn. Force of gravity is down, friction's left, normal's up, and we already talked about tension. I've already looked to see how tension's broken down in its x and y components. One more piece of information we need is that the angle is 40 degrees. So first thing I'm going to do is I'm just going to figure out what are my tension in the x and tension in the y, because I'm going to need to know both of them. Tension in the x is the adjacent side, so I'm going to use cosine to find that. So cosine of my angle, 40 degrees, times the tension itself, which is 85 newtons, will give me tension in the x, and that's 65.1 newtons. Now we're going to do tension in the y. Tension in the y is the opposite side, so I'm going to use the sine of the angle, 40 degrees, multiplied by 85 newtons. And when I plug that into my calculator, I get that the tension in the y is 54.6 newtons. So now I have both of those components of the tension force. So now we're trying to find acceleration. It's going to accelerate toward the right. So what is my x equation for this particular object? I know that my tension in the x is a positive force because it pulls to the right, and I have the force of friction pulling to the left. And those two together equal ma. To solve for A, I just have to divide by mass. So I would have tension in the x minus my force of friction divided by mass equal acceleration. We know what tension in the x is. We just solved for it a second ago. But we don't know what force of friction is. But we have an equation for it. So tension in the x minus friction, which we know is the coefficient of friction, times the normal force, all divided by m, will give us acceleration. But the problem is, we have tension in the x, we have the coefficient of friction, we have the mass, but we don't have the normal force. We have to solve for the normal force. And we have to add up our up and down stuff in order to solve for the normal force. Very common mistake. People want to just say that the normal is equal to gravity, but not in this problem because there's an upward pull as well. So here's what we have to do. Our up stuff is going to equal our down stuff because this object is not accelerating up and down. It's accelerating toward the right. So my equation in the up and down is going to look like this. My up stuff, normal force, plus tension in the y, has to equal my down stuff, which is the force of gravity. I'm trying to solve for my normal force, so I'm going to subtract that tension in the y direction over to the other side. And now I'm going to start plugging in some numbers. I know that the force of gravity is equal to the mass of the object times 9.8. And tension in the y we solved for as 54.6 newtons. Went a little bit off the black there, but that's okay. And when I plug all of this into my calculator, 15 kilograms times 9.8 minus 54.6, I should get a normal force of 92.4 newtons. Now I have all the numbers I need in my x equation, so I can just plug in and solve. Tension in the x is 65.1 newtons. The coefficient of friction is 0.3. My normal force is 92.4. And my mass is 15 kilograms. All of that gives me my acceleration. So when I plug all those numbers into my calculator, I should get an acceleration of 2.5 meters per second squared for A. So a quick recap, I figured out my components of my angled force, did that right here. Tried to find acceleration by adding up my forces in the left and right direction. Right minus left equals ma. But I got stuck because I didn't have what friction was. I needed the normal force. So I added up my up and down stuff. Up stuff equals down stuff. Plugged in my numbers, solved for the normal force, and then was able to finish my equation going left and right. The end.